Welcome to today's part of this SPSS methodology. This time with a unit on variance analysis and in particular multi-factor variance analysis. So as compared to the univariate, the one-factor univariate variance analysis, here in this case we're going to consider the situation where we have one dependent and two or more independent variables. Or in other words, we're going to split our data set up in groups according to two or more variables. In the normal variance analysis we used only one variable, making this univariate and one factor. Here we're using still univariate, only one dependent variable, and we're using multiple factors. So if we take a look at our data set, we see here we still could can analyze our weight, and we can split this up once by gender and secondly by BMI, classified BMI. Okay, so far so good for the intention. How do we actually proceed? How do we actually perform our two-factor variance analysis? So we go to Analyze, and no longer can we use with the compare means the one-way ANOVA. We have to switch here to general linear models, and here you can see we have univariate. That's basically what we're going to use here. If ever you use anything with multivariate, so more than one dependent variable, you go here, and in all those cases we always considered that this is with independent samples. If you were to have dependent samples, you would have to go here with repeated measures. So in our case we just use the univariate version. Then here we can add our dependent variable, the weight. Then we have different possibilities. We need to select our gender and the classified BMI, and we add them as fixed factors. This would already suffice. However, I will add one additional aspect here, and we do not have to go back in a moment. We go to plots, then we add the combination factor 1 as horizontal axis and factor 2 BMI as separate lines. Click on Add, and then we do the same thing but with opposite assignments. So we click again here at Add, Continue, then we basically prepared everything necessary, so we can click on OK. So first off we get a short overview, and then here we have our results. However, before we can actually analyze these results, we need to turn our attention to these two plots we additionally generated. Those plots need to be analyzed insofar as the factor described here by the different lines can only be suitably interpreted if the lines do not cross, do not intersect. Well, here this is given, so classified BMI can be sensibly interpreted, so we can use the results we've gotten above. Then we go down to gender. Here as well the two lines, male and female, do not intersect, so independent of whether they are below average, average or above average, men always have a higher weight than women. And here this would read as independent of whether it's below average, above average or above average, the weight is always higher for above than for average than for below average. So we have some kind of ordinal assignment. That's why we call this situation also ordinal. Same one down here. If it were only that one of them would satisfy this condition that the lines do not cross, then we would call this semi-ordinal, and if in both cases we would have lines which intersect. We would call this disordinal. So in this case, both of them show ordinal behavior, so we can interpret both our direct effects. So we can here interpret the direct effect of gender, and we can here interpret the direct effect of BMI. And in both cases, independent of the outcomes of this here, we can also interpret the interaction effect. So what we see here, first off, all three effects, the two direct effects and the interaction term, they are all highly significant, or this at least is significant, because it's the significance level here is still below 5%. Then we see that the effect of the interaction term is way smaller than for the other twos. So this is basically our first insight. We can interpret them, we know something about the size of the effect, but it's still not this well done. We also know here, if we take a look below, that we can, with our model, explain roughly 3/4 of the variance of the dependent variable, so of weight. If we want to know a bit more, we could return here to general linear model, univariate, then go as well to options and click here on estimates of effect size. We click on this, we get here an additional column, and this tells us how important each of the different parts of our model actually is. So the whole model explains 74.8%, so that's actually the same thing as the R² down here. And then this is split up in the 4 different parts of our model: the constant, the intercept, the direct effect of gender, the direct effect of BMI, and the interaction effect. Then we see, as we would have suspected already, here with the BMI for class, this is almost double as important as the gender variable. Intercept still has a very significant impact. So yes, there is an effect, a significant effect of those two variables, but still the constant makes up most of the explanatory power. Well, this then finally is all I wanted to mention in this first introduction to multi-factor univariate variance analysis. We could go into more details. We would have the same possibility here as we had with the normal univariate one-factor variance analysis, that we could go and take a look at post-hoc tests, assuming again we have equal variances or we have unequal variances, so we could test the different subgroups, whether they are similar or dissimilar. But in this case we won't go into detail here, and basically we wouldn't get any additional insights which we wouldn't have seen before in a part on variance analysis. So I would like to conclude at this point, and I hope you learned something from this section and you enjoyed listening to it. If you want to see more of this type of videos, feel free to visit the rest of this SPSS methodology. Until then, see you and goodbye.